Welcome back, dear friends. This is an interesting course on financial analysis of energy audit and solar projects. And this is our third lecture in the series. And we would be learning a very interesting concept, namely the concept of time value of money and the associated concepts of present value method and net present value method. You would be really enjoying this video in the sense that it gives us very interesting insights about how the financial analysis is done. The outcomes expected is you would be learning the present value method and net present value method in this lecture. The overall expectation from this series of video lectures is that you would be independently doing the financial audit of energy audit and solar proposals. So in this lecture, I would be concentrating on the present value method and net present value method, and the need for present value and net present value method arises because of some limitations of the simple payback period method. So if you remember the discussion which we had in the last lecture, we talked about a simple payback period, and we said that simple payback period has an advantage that it is very simple to calculate, in the sense that it is simply a ratio which we calculate, and it is a ratio of investments upon the cash flows. So when you talk about a simple payback period, the answer which we get is in the term of period or the time which is required for getting our money back, the investment which we have made as an investor, how much time is required for that money to be paid back. That is called as a simple payback period. The advantage, as I said, is it is very simple. We can calculate the simple payback period as a back of envelope calculation and can be used for assessment of the energy audit projects and solar proposals. We took an example of solar water heating and solar photovoltaic projects, and we also talked about an energy efficient lighting proposal, and we showed that it can be easily calculated. The simple payback period can be easily calculated for energy efficient lighting as well as for solar water heating projects with a very small amount of data. So what is the disadvantage of the simple payback period method, and why are we discussing some other method? So the disadvantage of a simple payback period method is it favors the projects having quick returns, in the sense that if you look at the simple payback period expression, what is that? It is investment upon savings, and the calculation stops when the recovery is done. So the simple payback period, if you remember the example of our calculation of the solar water heater, wherein we talked about the savings, the electricity savings because of using a solar water heater, and we got the simple payback period as 5 years. So how did we get that? So we got that 5 years as a simple payback period by considering some investment and the savings. When it became equal to the investment, that was a period of 5 years. But you know that solar water heaters have a typical life of 15 years. So it means that we are not considering the savings beyond the period of simple payback, right? For example, in solar water heater, we are not considering the example which we had taken. We didn't consider the savings which we would be getting beyond 5 years. Okay, so that way it becomes a disadvantage, especially if the projects are having long-term returns. Means suppose you have some proposal wherein you are going to get savings, small savings maybe, but over a period of 50 years, right? So that projects would not be favored. Perhaps if you are using a simple payback period calculation, it would be favoring a project which is giving you quick return, right? For example, if you consider a small investment project which would give you savings only for 3 years, and the simple payback period is 3 years, whereas vis-a-vis another project which has got a larger investment, but you are going to get savings of, let us say, 20 years, then the simple payback period would err on this side. It would make a mistake in favoring a project having a simple payback period of 3 years. Okay, so I feel that I'm sufficiently clear on this. We need to understand clearly that simple payback period, though it's simple to calculate, it might create an error in favoring the projects which are having quick returns, and it would do a disfavor for the projects which are having a life cycle savings, long-term savings. This is the first disadvantage. The second disadvantage is that the simple payback period does not consider the time value of money. Now, what is this time value of money? So let me show you a very beautiful picture here. This picture is drawn to explain you this concept of time value of money. As I said, simple payback period does not consider time value of money. Now, what does this mean? If you look at this line diagram, what you say is that there is some initial investment C0, and you are getting savings of C1, C2, C3. Now, somebody would say that, okay, the total savings which we are getting is C1 C plus C2 plus C3, the algebraic addition of C1, C2 and C3. But in reality, the savings which you would be getting would be less than C1 plus C2 plus C3. Why is that so? That is because the money which you would be getting C1 after 1 year, for example, that would be it would be less worthy than suppose you would have got C1 on the day 1. Okay, means during the start of the project, if you had got C1, that would have been more valuable than the C1 which you get after 1 year. Similarly, if you are getting C2 in the second year, then that C2 would be less valuable than suppose you had got that C2 on the day 1. Okay, similarly, C3 would be less valuable when you get the money after 3 years than, say, if you had received that money in the start of the project. It means that the value of the money, generally speaking, would be reduced, okay, as you go to the future, right? So the present value is worth more than the value which you'll be getting in the future. So that is the meaning of this proverb also, that if you are getting a bird today, it is worth more sometimes if you are getting, even if 2 birds which are in the future, which you'll be getting in the future. Okay, so the concept of time value of money is that we should value the money which you would be getting today, right? Now, what happens in the simple payback period calculation is that the savings which we get in the year 1, year 2, year 3, let us say if we are considering a project having a simple payback period of 3 years. So we actually value the savings after year 1, year 2 and year 3 as equivalent to the investment which we had made in the year 0, right? So the savings we would be considering as the same, as having the same value as we have the investment which is made today. That is not the case. The savings, as I said, would be less valuable, less worthy, and that is not considered in simple payback period. So what has to be considered is the time value of this C1 has to be considered. Means we need to discount the value of C1, we need to discount the value of C2, and we need to discount the value of C3 and arrive at the present value of C1, C2, C3. So the present value of C1, C2, C3 will be less than C1 plus C2 plus C3. And how do we discount that? So for discounting that, discount rate has to be used. Now, what is discount rate? Discount rate is just the opposite of interest rate. Interest rate is the rate which one gets if you invest the money in the bank, right? And the interest plus capital we would be getting in the future. Now just think the opposite way. If you are getting C1 in the future, and if you want to get the value of C1 today, then that value is less. So we need to discount it. And how do we discount that? So the present value of C1 by using the concept of discount rate would be C1 upon 1 plus D. Please note, or 1 plus R, if R is a discount rate, right? So C1 upon 1 plus R is the present value of C1. C2 upon 1 plus R square, the bracket square, 1 plus R bracket square is the present value of C2, and C3 upon 1 plus R bracket cube would be the present value of C3, right? So a correct way of valuing the savings which you would be getting in the future is to apply a discount rate R, the discount factor R, and compute the present value of the cash flows which you will be getting in the future. So C1 is the cash flow in the future, C2 is the cash flow in the future, and C3 is the cash flow in the future. Its value is not C1 plus C2 plus C3. Its value is C1 upon 1 plus R raised to 1 plus C2 upon 1 plus R raised to 2 plus C3 upon 1 plus R bracket raised to 3. Now, if you want to express this concept in the term of expression algebraically, it would be summation of CF raised to CF n, from where n is the number of years, upon 1 plus R or 1 plus I raised to n. Okay, so either you can use the term I for interest rate, or D for discount rate, or R for discount rate, whatever term you use. What it means is that we are discounting the cash flows which you are going to get in the future, right? And what do we do then? We compare this present value with the initial investment C0. If we get this present value as greater than C0, right, it means that your savings are on the positive side. Are you getting this point? I'll repeat this. What is the present value of C1, C2, and C3? The present value of C1, C2, and C3 would be C1 upon 1 plus I or 1 plus R raised to 1 plus C2 upon 1 plus R raised to 2 plus C3 upon 1 plus R raised to 3, where R, or you can call it as I, or you can call it as D, is the discount rate of interest applied in the reverse, right? So that becomes the present value. And if that present value, if you subtract C0, the initial investment from it, that becomes the net present value. So what is net present value? C0 is the initial investment which has to be subtracted from the future cash flows, right? And then that gives us what is called as a net present value. So present value is only this first term, and if you subtract the initial investment from the present value, that becomes the net present value. And how do we evaluate the proposals using the net present value? If the net present value is positive, then we would say that the proposal is economically viable. So we would always aim for the net present value which is positive. So from the economic perspective, if you want to do a financial analysis of, let us say, an energy audit project, then what we need to do is that we need to sum up the cash flows by considering the time value of money, and then we need to subtract the initial investment of that proposal. And if we get that as a positive term greater than 0, then we would say that on the net present value method, using the net present value formula, that proposal is a financially viable proposal. I hope this is very clear to you. It would be more clear when we take examples based on this. Thank you very much.